My name is Magda, and I'm very happy to talk to you today about one of my favorite subjects, property-based testing. But to be honest, when I first met property-based testing, I wasn't too impressed. It was during my first months of writing Scala that I noticed that in every Scala project that I join, there is something called property-based testing. And I didn't know what it is. So at first I thought, well, that's just another Scala thing. So I will get to do the same thing as usually in Java, but I will have to learn to do them the Scala way. But when I really got to know what it's about, I thought, wow, no, now this is a game changer. This is something completely different. And it's really great. And the reason why I thought that is that because property-based testing, your job is to specify some kind of a rule about your code, and the job of the library it is to find edge cases, is to find bugs, is to find the places where you maybe don't understand your requirements so fully. So it's actually like as if the testing library did a lot of the heavy lifting for you. And so I thought, okay, that's great. So I can sit back and relax while the library finds bugs for me. But my second thought was, why am I learning about it just now? Why hasn't anybody told me about it before? This concept can be easily used outside of Scala, outside of functional languages. So today, I would like to do just that. I would like to show you that property-based testing exists. I would like to tell you that it's great. You should start using it. I would like to show you how you can start with it. And the plan for the next 45 minutes is for me to explain the key concepts, to show you the code, how it looks like, to show you which libraries you can start using. And in the second part of the presentation, even though I'm really excited about property-based testing, the second part of the presentation, I will tell you where property-based testing is maybe not such a great fit, what are some caveats, what are some of the things to watch out for, and some tips and tricks from my experience. And if you have attended Kai's great talk earlier, I will touch on some of the concepts that he mentioned there, and I will expand on some of the others to get the kind of a general understanding about property-based testing as a tool for testing in your project. So let's start. And the best way to start would be with an example. Let's imagine our sample domain. Let's say we have a feature where we have to calculate discounts for our customers. So this is the business method that we would like to test. It's calculate discount. It takes an instance of customer, an instance of now, of a local date, and it returns big decimal. And here is our customer case class. So for each customer, we know their name, we know the date when they joined our company or our program, and we know their date of birth. And what our business method does, the business logic for calculating the discount, is as here. It depends on the number of years that the member has been with us. So if the customer has been with us for less than 1 year, we don't give them any discount. So this is just 0% discount. And because it's represented as big decimal here, it will be just 0.0. If the customer is with us within 1 or 2 years, within 1 and 2 years, we give them 10% discount, so 0.1. If they're with us for more than 2 years, we give them 20% discount. And just to make things a little bit more complicated, let's say if it's the customer's birthday today, then we give them a special birthday discount, 30%, just this day. So this is our business method. Let's imagine I have implemented it somewhere. I will not show the code right now. And let's see how we could test it. And at first, I would like to show you the traditional way of testing it. So opposed to property-based testing, we can call traditional tests example-based tests, because we have an example, we run our method, and we get the result. So how would I go about testing such a method in example-based tests? I guess I would come up with such test cases. For example, here that the discount calculator should return 10% discount for a one-year member. So a really simple one. I just have a date of birth, whatever, but it's just not the customer's birthday today. I create an instance of customer. I give them a name. I say that they have joined 1 year ago, and this is their date of birth, not relevant. So then I run my method. So calculator calculate discount given now date, and I have an assertion that the discount should be 10%. And a very similar test case for 20%. So I have a customer who has joined 2 years ago. It's not their birthday today. I'll calculate the discount and verify that it's 20%. So this is all cool, but let's also take into account our birthday discount. So we are now creating a customer who has joined 1 year ago, and it's their 41st birthday today, I guess. We run our business method and we verify that it's 30%. So right now we have all the happy path covered, but we know this is not enough and we have to take into account the edge cases. So what test cases for edge cases can we think of? I guess I would think of such two test cases. So 0% discount for a new member. So I'm creating a customer who has joined just now. They are very new. And we verify that the discount should be 0. And also, let's just make sure that the discount doesn't grow indefinitely. So if a customer is, I don't know, 10 years with us, they don't get 100% discount or something like this. So let's say that for a free-year member, we should still return only 20% discount. So we're creating a customer who has joined 3 years ago and verify that for them, the discount is 20%. So now if I provided such test cases, I would pat myself in the back and say, great job. I have provided the test cases for the happy path and for the edge cases. So it's all good, commit, push, and move on with life and start with a new feature. And now let's see how this all would be different in the world of property-based testing. So if we're saying this is property-based, then what exactly is this property that we have to provide? Now, property is some kind of a rule about your code that has to be always true. So no matter what input you provide to your method, this rule has to be obeyed for every case. And as I mentioned, your job is to think of such properties, to specify such properties, and to write them as in the form of test. And the job of the library is to generate the data, run your test many times, and verify where your property fails. So how would it look like for our case? Here, the important thing is that the properties don't always specify your code in 100%. They're often some kind of invariants, some kind of approximations, or some kind of safe boundaries, so that you can make sure that if you generate some crazy data for your input, then your output is always within those safe boundaries. So what kind of properties could we think of here? For example, we could say that for every customer and date that we provide to our method, the result is never less than 0. See, it doesn't define all of our business logic, but it's something that is always true. It's a safe boundary. And similarly, we could say that no matter what the input, the result is never bigger than 30%. So it's never bigger than 0.3 actually in big decimals. So these are already two properties that we could have. What are some other properties that we could specify here? If we have two customers and one of them has joined very early in the past and the other has joined just recently, then we can say that the discount for the older one is always bigger than discount for the younger one. That's a very nice property. And similarly, to take into account our birthday discount, we could say that if one customer has a birthday today and the other one doesn't, then the one with the birthday has always greater discount than the other one. So these are the kinds of properties that we could specify here. And right now I will show one of them written in the code. But before we jump into the code, let's have a word about history. So as opposed to many things in computer science that were discovered in 1970s and we are still discovering it again, the property-based testing has been with us for just over 20 years with the implementations in Haskell and Erlang. And since then, a lot of implementations and libraries have been created in a lot of the languages, and this list here is not complete for sure. However, an important thing is that not all of these libraries are equal, because as I mentioned, in property-based testing, the library plays a special role. It does the heavy lifting for you. So it can help you in a very good way, in a very sophisticated way. It can help you a lot, or it can be just basic and have the basic features. So where is Scala in all this? Well, Scala has great support for property-based tests. And what are the libraries that you could use? For sure, you might have heard in ScalaCheck in terms of property-based testing, but you might have also heard about ScalaTest in this context. So what are they? Are they alternatives? Well, not really. ScalaCheck is the property-based library, property-based testing library. So it specifies in property-based testing. It's just a tool created for that. It's a very good tool. And on the other hand, ScalaTest is the general testing library in Scala. So if you have some tests in Scala, they're most probably in ScalaTest. And ScalaTest supports property-based testing, but it doesn't have its own engine. It uses ScalaCheck under the hood. So if you have property-based testing in your project in ScalaTest, then you are actually using ScalaCheck as well, but under the hood. So your choice really is to decide whether you want to use plain vanilla ScalaCheck or use it as part of ScalaTest. And which one to choose, which is better? This is a tough question because for me, from my personal point of view, ScalaCheck is a great tool. It's got great defaults, good configuration, and the output, for example, when something goes wrong, is just very informative, very good. On the other hand, ScalaTest has its own advantages. For example, it's got this nice DSL, and it can be consistent with the other tests that you have in your code. And for me, the readability of the tests is very important. So actually, even though I prefer ScalaCheck constants better, I use ScalaTest because I like to read my tests. I like to make them read as prose, as a good story. So I prefer ScalaTest. However, this is not the only thing you can choose, because ScalaCheck has its quirks and not everything is maybe as easy as it might be. And there's new effort to provide more libraries which address some of these difficulties. One of them is the Hedgehog library. It's very promising, and I would like to use it one day. And also there's Zio support for property-based testing. So something to keep an eye on if you'd like to use something just newer or be more experimental. So now that we have the libraries, let's finally see the code that we've been waiting for. So I will write here this property that I have mentioned, that the discount is never larger than 30%. Let's see how it looks like in a test case written that you can have in your project. So here, the main part of the test is very similar to what we have seen before. And oh, by the way, this is in ScalaTest. And all the examples in my presentation are in ScalaTest, but all the concepts can be easily written in ScalaCheck, Hedgehog, or another library in another language. The concepts are the same here. So here, as the implementation of the test, we run our method and we verify that the discount should be not bigger than 30%. So this is clear, but all the magic happens here in this for all. And what we are doing here is we are saying, dear QuickCheck, please provide for me 100 such pairs, random pairs of customer and local date, and please verify for me that this property is always true. I said random, but this is not randomness. This is actually something better than randomness. It's something that I sometimes call nasty randomness or mean randomness, because the library tries to be tricky and it tries to find you some special sets of data that will make your test fail. It tries to find the edge cases that you haven't really thought of. So the example of such nasty data, for example, here we have complex types, but if we had simpler types, maybe strings, then you could be sure that among the data generated, you would have an empty string, a very long string, a string with maybe Polish characters, maybe kanji characters, or maybe non-printable characters. And your code would have to endure that. If we were talking about numbers, we would have 0 for sure. We would have the maximum number from the date range, the minimum number, and so on. If we had lists, we would have empty lists, very long lists, lists with the same element just copied over and over again, and so on. So it tries to find problematic data for you. And this is one of the things that the library can be great at, or it can be a bit more basic. It's how tricky and how nasty data it finds for you. So what happens if the test fails, if the library finds that something is wrong? This is an example from our domain. This is something that happened. So can you see what the problem was? Of course, you can see it instantly that it's February 29th. So it's leap year. So it turns out that in my implementation, I have made a mistake and I didn't take into account that leap years exist. And see, this is the thing that property-based testing is just great at. It finds the edge cases that you haven't thought of at all. Because when we write our code, we are biased. We think about a couple of examples and we base our code on it in our heads. And the same with tests. And property-based testing library, it's not biased. It will throw tricky data at you and it will find the bugs in your code. So this is nice, but how do we generate the data? We do it with generators. And if you have seen KaiStock, you have seen that you can use generators to actually generate test data. And I have also done that. I think that's a great idea. But generally, the idea here is to is to have generators which will create data which is very weird, but correct in terms of your domain. So if the generator creates some data that is invalid for you, then even if your test fails, it doesn't prove anything because that's some input that you don't even have to care about. So you want to make sure that your generator is fine-tuned to your domain, your project, and it produces exactly such values that you should care about. And in every library, you will have the generators out of the box for your base types. So for example, for numbers, you could have positive numbers, ints or longs. You could have numbers from a given range. You could generate lists of a given length, and the elements of the list, it can be a result of some other generator. You can generate UUIDs, options, given sets of data to choose from, and so on and so on. So I encourage you to have a look at these gen methods to see what else you can use right away. But sooner or later, you will find the situation that you have your common specific type that you need a generator for. So what do you do then? Well, you combine the generators and create generators on top of generators using other generators and so on to have the perfect generator. And an example of such custom generator, let's show here. We have our customer type, so we need to have a gen parameterized by our customer class. And the way it usually looks is it's a for comprehension where what you yield is the customer, but you have to specify the name, date joined, and date of birth. So for this, we use other generators. For name, we're just using a simple alpha string generator. And what are we doing for the dates? These are two dates, but they are different dates in our domain. So they need to be generated from different date ranges. So for this, I have provided my helper method, date from range gen, where you provide the start and the end of the range. And for me, the start of the range for when a person can join is just some kind of a constant. I need to ask my product owner about that. And the end date in the range is now. And for the date of birth, I don't know how old is the oldest person on Earth right now. I have no idea, but this is something you have to ask your product owner. They give you a constant and you use it here because you have to have the range. And let's say we need to be 18 years old to take part in our program. And the implementation of our helper method, it takes start and the end of the range. It returns a generator of local date. And what we are using is we are using a built-in range. It's a range of longs. So gen.choose, you convert the date to long to epoch day. You get from this a result of the generator of the date, and you map it back again to local date by using local date of epoch day. So this way I have a helper method providing me the date range that I need, and the result will be just any date from within the start and the end of the range. So this is quite a simple entity, but in your project, you might have even much more complicated entities, and it's a great idea to have great generators for them. So if you think this is complicated, then I agree. But for me, it's fine to have hundreds of lines which define your generators, which are perfect and specific for your domain. And sometimes when it's not enough, there are some other tools that you can use. In chi-stock, for example, you could see frequencies to make sure that some of the data is represented more often in your generated data, and some of them not as well, not so much. And another useful tool are assumptions. So this is this whenever thing here. So to explain what they are, let's have a look at the other property that we have specified, that the birthday discount should be higher than the discount for a customer who doesn't have a birthday. So for this, we generate two customers, and we say that we just set one of them's date of birth to today's date. Actually, the other way around. We set now to their date of birth, but with another year. But we want to make sure is that it's not the other customer's birthday. So we want to say that, dear Quick Check, for all of the data that you generate, please only filter out and take just those which passes this assumption. So right now we can say that the one is ordinary discount. We calculate the discount for the ordinary customer, and we calculate the discount for the other customer. And then we can compare, and we know we want to make sure that it's greater than 0 and not greater or equal, because they cannot be equal. So one thing to be careful about here is you generally want to make those assumptions quite easy to pass. Because if your library generates 100 data for you, and then has to discard 95% of the data, then your test isn't so great because you thought you've got property-based testing and a lot of input data, but in fact you are just testing 5 of it. And in the world of property-based tests, 5 is not so much. Actually, another thing to keep an eye on is that in ScalaTest, the default number of tests run for each such a test case is 10, whereas in QuickCheck, it's 100. And I think 100 is a great constant. And 10 is not so much. So if I were you, I would just set the configuration to 100 for each of your default tests. Unless it's a test which, I don't know, talks to the database or is very long and so on, and you just want to be quicker and you don't want to do it so many times. So this is a helpful tool to make your generator perfect and to make your properties say what you really want to say. So this is all great. But we have now come to the second part of my presentation called challenges. Because if property testing is so great, then does it mean then that tomorrow you should go back to your project and delete all example-based tests and only provide property-based tests and so on? Of course not. There are a couple of reasons why example-based tests still have to exist and coexist with property-based testing. And I will explain 4 of such challenges which are quite important in my opinion. Challenge number 1 is that property-based testing makes you ask difficult questions very, very early in the process. Because see, what we did earlier was we had to answer, even before writing our first line of test code, we had to find the answer to the question, what is the oldest person that can be part of our project, part of our program? You have to specify the input data that are correct for your generators before you write the tests. So I don't know, the other questions could be, what is the longest surname a person can have? What is, in financial companies, what is, for example, the highest number a person can spend on newspapers per day? Or what is the highest salary a person can earn? And so on, because you have to define those input ranges. And you then have to go back to your product owner and ask those things. And they ask you, okay, so you are asking about edge cases, so are you almost done? And then you say, no, I have not started yet. So this is something a bit different, and you have to get used to it. The second challenge, and the biggest of them all, is coming up with properties. Because here I have shown you a couple of properties for our example domain, and this is fine. But when you go back to your project tomorrow and you try to come up with properties for your project, it might not be so easy. And this is not easy, but don't worry, you will get better at it with experience. And smart people have thought of some patterns, and we love patterns, don't we? So there are some list of patterns that you can consult for an inspiration to come up with properties. And I will show you 4 such patterns as examples. First one is Oracle, but not Oracle as in company name, but Oracle as a person who knows everything. So if you are lucky enough to have the implementation of the same thing that you are doing somewhere else, maybe in a different package, maybe not so quick implementation of sorting, but just another implementation, or maybe even in a different language, and you can compare the results of that Oracle with your implementation, then you are a very happy person because you can verify the correctness of your implementation with properties. And for example, in my experience, I used to have some sophisticated financial calculations to do, and you could download the specification of it from the regulator's website in the form of a spreadsheet. And if you put some values in the spreadsheet, then the macros worked, and in the other cells of the spreadsheet, you had the results. And my job was to write the same kind of calculations, but in a different way in my system. So what I did in my tests, what was I generated sample data using properties, using property-based testing. I then opened the spreadsheet, put in the data in the cells, run the macros, and compared the results with my implementation. And it was a very long journey to get my implementation to be correct. With all those financial decimal calculations and so on. But this is the kind of thing that I'm talking about. And here again, if you are doing some kind of file opening, closing, I/O, and so on, then it might be the case where you really want to run your test maybe 10 times and not 100 or not 500. Another kind of pattern is called alternate wording. And this is something that works great, for example, with a colleague when you are brainstorming. So what you do is you talk about what your business method does using different words. So if you have to sort a list, then you can say, well, my method, the output of it is a sorted list. Well, this doesn't tell us much. But if we say, if you take the output and you compare the pairs, then the second number of the pair is higher or equal than the first number of the pair. And this gives us a great property because you can compare the pairs, and this way, not repeating your implementation, you have a property that has to be true for all of your sample lists and sample numbers. So this is the process where you have to be creative. And actually, when thinking about properties, you always will have to be creative. So sometimes you will have to take a break and maybe go for a walk, and your subconsciousness will give you some property, or maybe you will have to talk to your colleague, or maybe you want to work on it fresh in the morning when you have a lot of energy. This is a creative process to get the perfect property for your implementation. Another simple but powerful pattern is invariant. So some things never change. For example, in our example, we saw that the discount is never less than 0, is never higher than 30%. So these are invariants. In case of ordering a list, for example, the number of elements in the list is the same, and so on. So if you have those invariants, then this is a great property, and you are providing the safe boundaries. No matter what crazy data you throw at your method, it behaves in a sane and decent way. And another pattern is symmetry. So sometimes you have the opposites somewhere in your project. For example, maybe you have serialization and then deserialization. Then you can test those two processes together and just compare that at the end. You have the same as at the beginning. Another example could be inversing a list. So you inverse it and then inverse it back again. Or for example, maybe writing to a database and reading it back from the database. This is simple. You can easily think of such property tests, but they often find very nasty bugs for you, for some weird generated data that you didn't take into account. And another challenge, the third challenge of the 4 that I would like to explain, is non-determinism. Don't we all hate non-determinism? So for example, let's imagine that we are writing our test. It's a property-based test. It's green. We push it to a continuous integration server, and it's great. But then a week later, it fails there. And what do we do? Do we say, oh, it's a flaky test, let's ignore it? No, of course, you cannot do it. You have to go there. You have to see what kind of data were generated, what is the problem there, and find the root cause of this one specific set of data that is a problem. Because what it means is that the library has just found a bug for you, and it probably has found this bug before your client did. So it's not perfect that it's in a week, but it's still better than, I don't know, 1 year later when your client does it. So what you have to do is you have to analyze the root cause and provide an example-based regression test for it to make sure that you have this bug always covered, you have it fixed, and that in the future, no one will introduce this bug again, because then you don't know when you will get to know that it was broken again. So as you see, this is one of the reasons why example-based tests are still very, very important to be besides the property-based tests. And the last challenge is documenting. In my opinion, one of the ways tests are great and one of its roles is the documenting role. For example, for me, when I try to find what a new feature does, or actually a new piece of code that I haven't seen, I often open the test file and I take a look at the simplest happy path scenario. I've got a simple example, I've got my method, and I got the result. And it's often everything I need at that time. A concrete example, and at this point, I'm not interested in some approximations, some invariants, some general rules, because often what our brain wants to quickly understand is a concrete example. And property-based tests are not so great for documenting. So it's very useful to have both example-based tests and property-based tests. Okay, so this is all nice and fine. As we are nearing towards the end of my presentation, I have shown you that property-based tests are great. They give you real value because they can find the bugs for you. But on the other hand, they are not so trivial, not so straightforward. They may be hard to write, and it's a lot of effort. So what should you do? I would like to leave you with two alternative strategies that you can take if you'd like to start with property-based testing in your project. The first one is example first, properties later. So when you write a new piece of code, just start traditional way. Maybe start with test-driven design. So provide a very simple test, very simple implementation. There are more sophisticated tests, more complex implementation, and so on and so on. And maybe then start to think about edge cases, as I have shown you on the very beginning. Find the bugs with the test for these edge cases. Go back to your product owner, talk about the what is, the oldest person on earth, and so on. And once you have this traditional way and you think you got your story right, only then start coming up with properties. And it may find you new knowledge. It may discover some holes that you had in your understanding, in your requirements. It may find you edge cases that you never thought of, and so on. And by doing this, you have a journey. You are embarking on a journey with your code from the simplest to the most complex and weird edge cases that you can get. And the second strategy is, if we say that property-based testing is not something that you can write very quickly and it takes some effort, then maybe only start writing them for your key components. And what does it mean, a key component? It can mean, for example, the most difficult part of your project. maybe some, I don't know, financial or accounting stuff, maybe something that no one really is sure how it works. Play with property-based testing with it and discover what you can find with coming up with properties and discussing them with your colleagues. And the other meaning of key components can just mean the core components of your business. So those that if you get it wrong, somebody will lose money. Maybe your client will lose money, maybe the users of your client will lose money. And you just want to make sure that you did everything you can to make it as correct as possible. So with this definition, you can provide the properties for the most key components in your system. And this is a second strategy that I recommend. So to sum up, property-based testing is something that doesn't come for free, but on the other hand, it gives you the value that other kinds of tests cannot provide you, because here the library can find the edge cases that is out of your biased way of thinking. So it's higher cost, but you give something in return. You get something in return. Where it really shines is in finding edge cases and misconceptions in the way you think about your code. So it's a nice base for discussion. The tricky part is coming up with properties, but you've got the list of patterns and you will get better with experience. And the balance. Well, I cannot tell you, for example, then in each of your project, you should have, for example, 60% example-based tests and 40% property-based tests. Because all projects are different. They have some of the complicated parts, some of the trivial parts, and so on. But if you are able to find the right balance between example-based tests and property-based tests in your project, and you have the perfect generators and the perfect properties that you can think of, then it means that you have done everything you could to make your code correct for all the edge cases that you already know about, and also for the ones that you have never even dreamed of. But the library is trying so hard to find it for you. And if you'd like to know more, please have a look at both ScalaTest and ScalaCheck documentations for the feature that I haven't covered here. Please have a look also at the third link. It's a series of blog posts about Erlang property-based testing, but it doesn't matter that it's in Erlang. It's just a great way to get you thinking differently, coming up with properties, and also finding the learning to know about the features that I haven't covered. And the fourth link is this list of patterns that you can consult. So I highly recommend it for you to bookmark it and consult it whenever you start coming up with properties. And the last one, all the examples from this presentation live in a GitHub repo under the last link. So if you'd like to have a look how it works and does it find the bug straight away, or do you have to wait some time until the test is read, feel free to take a look. Thank you. If you have any questions, I will be happy to take them now. And if you have any feedback that you'd like to leave about the presentation, you can scan the QR code here. And under the QR code, there's also a link to these slides with all the links. Thank you.
Hi, thank you so much for your talk and being with us today.
Thank you. It's been a pleasure.
We have a handful of questions, so let's jump in. How would you go about finding the properties in your program or service? What would be the thought process or recipe?
Okay, so I think for me, the easiest thing would be to have a look at this list of patterns, because by reading that, you can have an inspiration to see if you can either reward your problem that you are trying to solve, or just find invariants or symmetries or things like that. And when you start with that, then you will start this different thought process, and you will your brain will just find more properties there.
Okay, thank you. Our next question, how does it work if there are mocked calls in the method? Do we always need to use when parentheses or then with NET since the data is generated by the generator?
I'm not sure if I understand the question in full. Maybe we can take it after the presentation. We can talk on chat so that I'm sure what this question is about. Sorry.
That would be lovely. There is a tool to link in Hopin itself, so we can make sure that this question gets answered offline or off air. The next question. Did it ever happen that a test case runs through 100 times and starts failing suddenly with the next run, just because the data is different? Is there a way to circumvent this?
Yes, it did happen to me that a test case runs hundreds and hundreds of times and that it's okay, and then it starts failing because it's just random. It does have this random seed beneath it, and if you don't like it, and for example, if your test fails and you would like to repeat the failing test, then in QuickCheck, at least, I think, when the test fails, you have the seed printed. So we can take the seed and use it as a parameter method to your next run so that you get exactly the same set of data generated again. So that's one of the ways you can circumvent this.
Thank you. Our next question is, how would you apply property-based testing for concurrent programs, like detecting deadlock or live lock, or detecting probable non-determinism?
That's a tough one, really. So if you know what kind of deadlock, for example, you could expect, then in my experience, it might actually be simpler to just use a traditional example-based test if you know how exactly to replicate it. And if not, then you can think of property-based testing as something that just runs your test 100 times. So maybe it's just more times to run, and it will find something for you if you are not really sure how to replicate it.
What a great question. Thank you. We have a couple more questions here. The next is there a way to see what data was used in the test that passed? If not, how do we know if edge cases were actually covered?
So for sure there is the way to print the seed, but this is not enough. And I'm sure that there is somewhere a way to just print the data provided. One thing that happens is that when the test fails, then you know the data on which it has failed. And sometimes, as Kai mentioned, there's this shrinking that you get the simpler example, which already fails your test. But it's true that if your test passes correctly, green, then I think by default you don't have a lot of data. So you would just have to add some printing there to the generator or to the test method.
Okay. What seems to be our final question at the moment is, how do you make sure that the property you came up with is true? I assume it's possible that you can come up with a false property, but how do you check that?
So it has surely happened to me that I thought I have a property which is false in the sense that it's not correct. So what happened to me is that the test failed, and then I analyzed why it failed, and it turns out everything is fine with my code, but the property is wrong. It's just the thing that I thought is a rule, it's not a rule. So you just have to fix your test. It's not so useful because it doesn't find a bug for you, but it will just make your test better.
Thank you. What great questions we had, and
thank you.
What a wealth just well-rounded session. So thank you so much for being here and for answering all of those questions. I hope you get to enjoy the remainder of the conference.
Thank you.
And
I will.
we'll see you around for the rest of the week.
Thanks. See you.
Yeah.